Hi there, everybody. Isaac Kenley here. Welcome to my channel. If you're returning, thank you for watching again. Today I'm going to talk about distributed ledger technology, architecture, and design for blockchains. Private blockchains are already being used, improving to increase continuous delivery time by over 30% or more. And when used by banks, they're decreasing transaction costs and they're reaching more customers who previously had no access to capital because transaction costs were too high. So I'm going to get right to some of the architecture being used today. Bear with me, please. Okay. So I'm not going to go into the front end area. Hyperledger's Sawtooth is a technology that enables you to separate your front end development area from your back end development area for security reasons. Hyperledger Fabric, which is written in Golang, is a great tool to create events and work with nodes and other features in your smart contracts on your distributed ledger technology. Hyperledger Composer, which is part of the Hyperledger family, is written in JavaScript, whereas Hyperledger Fabric is written in Golang. Hyperledger Cello is written in C, and it works more with the configuration. Hyperledger Composer is more of a front-end tool. These you can work within Docker containers. Docker containers are very useful to contain your work and development environment so that you can test your development and your software before it's actually deployed. And because they're containerized, it doesn't affect any of your current systems. Kubernetes works very closely with Docker as a development production tool. This is kind of the server area up here. With Zookeeper and Kafka, you're able to create a quorum of nodes. You have to have at least 3 servers with Zookeeper and at least 4 with Kafka. This is in case one of them goes down, the others can take over. You have to have a majority of nodes working. So you can't have just 2 servers, because if one goes down, how are the transactions going to be verified? These nodes listen to each other in a server environment. And so when you're processing transactions to Hyperledger, you can these nodes approve them, and if a majority approve them, then they're processed and then sent to an orderer and somebody who then commits them. Hadoop, of course, is for your data. It works hand in hand with Zookeeper, and Jenkins works hand in hand with these two, Jenkins being more on the server side. You can work with these servers if you already have them, or you can create servers on your own platform and migrate them over. If you are creating a completely new system, you can operate these in the cloud, like with AWS. Your smart contracts, you can create private smart contracts that operate on your own ledger and within your own containment area on GitHub or some other repository where developers live, pretty much. And this is all done inside Docker. Docker Composer is where you compose your programming, and that's written in Python. All of this up here is written in Java, so if you have a back-end developer working in this area, I recommend Java Programmer. Docker, I recommend Python. Hyperledger Fabric is written in Golang, and Hyperledger Composer is in JavaScript, and Hyperledger Cello is in C. There's a lot of bash scripts that have to communicate with each other to create events with your smart contract, so that when you have an orderer or a takeover and a process happening that's going back and forth, these things can listen to each other, create events, and if the transactions are approved, they can be processed. All this very fast. When you're dealing with quantum computing, in the blockchain area, things are happening so fast that it's just unbelievable how fast these things are moving. There's a lot more I could go into. I just wanted to list some of the technologies. I'm available as a consultant. I have experience setting up a lot of these things. I'm a software architect and designer in relation to blockchain technology, with my focus being on the back end setup process. So I actually have other videos where I have set up a lot of these systems and program them so that they can listen to each other and create events for your private blockchain. It's really simpler than it sounds. It's complex when you get to the final stage, but a lot of the beginning testing and everything is actually quite simple, although it can get complex. For example, just within Docker Compose, there's over 100 bash scripts that need to be written or run to be able to create events that listen to all your data, your smart contracts, your different flows, and back end and front end architecture. With your front end, you can have apps, you can have a gift card where somebody buys a security on a gift card or orders it through a text message. You can have microservices and modules that connect with public blockchains such as Ethereum or Bitcoin, and these can all be done. Your private ledger can communicate with a public blockchain through by pushing it to a public blockchain and creating atomic swaps. These nodes up here, when you have 7 servers and you've created a quorum of nodes that basically handled your data for your private blockchain, they propose updated transactions, and then they order transaction proposals, and then they notify your ledger for an update. And this can all happen in a Docker containerized zone and then all the way through to deployment. Docker works seamlessly with Hyperledger, Kubernetes, GitHub, and of course your data to be able to containerize all this so that you can test this without affecting your systems. And we have tools and diagrams and quality assurance programs that you can view to see all this happening. Well, I think that's all I'm going to go over today. I could go over more with smart contracts and how they work. I could spend a whole session on Hyperledger Fabric, and I probably will, so stay tuned. I'm available. My email's in my bio. I can travel anywhere to give presentations on blockchain technology, especially when it relates to this area of back-end development or blockchain architecture and design. Stay tuned, and thanks for watching.